For people who've been used to doing sort of traditional programming, errors are the thing you want to avoid. You're used to the idea that your program runs only until it hits an error, and then the computer kicks it out, and you've got to go do something. That really is not the way that programming should work. No matter how serious the error is, you probably want your program to do something after it encounters an error. Well, it depends what it is. Certainly, if you're we're talking about orienting programs towards working on beamlines, and certainly if you're working on a program that's involved in some sort of automation, you really don't want it to just, as one of my friends says, do this. You know, what's this? This is the opposite of this. So you really want to control how your program works. So dealing with errors is really an important thing in Python programming, and some people might consider this sort of an advanced part of of Python. I consider it really one of the most basic things you want to do is to think about how you're going to handle errors in your software. So we'll talk about the types of errors that happen, what happens in Python by default. We'll talk about how one captures errors and responds to them. We'll talk about using errors in your own coding. It's a really good idea. Okay, we'll talk about how you define your own error classes, and then we'll talk a little bit about some program strategies on how you may work with when errors occur. Okay, so errors are going to happen. You type, we just had an example when I was trying something out. Here's some code, it ought to work. It will generate an error. And it may or may not be obvious to you, but will generate an error because this code, because for with a capital F is not defined in Python, so this will generate a syntax error. This will generate an error before anything ever tries to run. If this were inside a script, we would get kicked out with an error before the script ever starts running. But more common is where we do something that Python will not allow in the course of our computation. Okay, so the statements themselves are valid, but what we've asked the computer to do is not. If you try to ask for the arcsine of 2, you're going to get an error because arcsine is defined from -1 to 1. Likewise, if you try to divide by 0, at least in the normal math library, you'll generate an error. So we've seen a bunch of errors already, and I just went back over the notes of what we've done and picked the ones out where we did something that generated an error. So it's worth looking. So we asked for an integer component of a complex number, gives us a type error. Likewise, when we try to change a tuple, we get a type error because these are errors related to the type that we're working with. When we try to assign a list with 3 values to 4 values, we got a value error. When we tried to assign make an assignment to an undefined element in a list, we got an index error. When we tried to work with a constant that didn't correspond to anything, we get a name error. So each of these types of errors has some category that it falls under. And these errors all are, as it will turn out, to be subcategories within what we'll call exception. So this is an exception type. So whatever you do at runtime that generates an error will generate some kind of error condition. What happens by default if you don't do anything specifically when you hit an error? Well, if you're just running a very simple script, that script will just stop and it'll bring you back to the command line. If you're running it from a GUI, and we haven't really talked too much about GUIs, But the way that a GUI works, graphical user interface works, is you set up a script, the script runs, and then the script goes into sort of a holding pattern, and that holding pattern is then waiting for things that trigger actions. So for example, when you push a button, you trigger an action. And if you hit an error without, by default, when you're running in a GUI, it will run through the script that you've given it to respond to, for example, that button, and it will stop when it hits the error, and then it'll just go back to waiting for more events. If you're doing things at where you're actually typing into the interpreter, it'll tell you the error message and then just come back and wait for a new command. This is really probably not what it depends what you're doing. If you're running some sort of instrument alignment code and whoever's going to be sitting there is going to be waiting to talk to the computer, then that may be fine. But if you are doing something that which is going to be running in some sort of fashion where it's running remotely or it's running in a automated fashion, you want to do something. And so Python gives us a very nice way to deal with errors using something called the try statement and then except. Actually, it'll turn out it's even more complicated than that. So, okay. So, all right, yeah. So let me just give you an example taken from my own code. Okay. Slightly edited, but not by much. Okay. When 11BM is collecting data on mail-in samples, it runs through a whole bunch of setup operations and then very quickly gets to a point where it says try, and then this routine actually does the data collection. And if it hits any kind of error, because all errors are fall into the category of exception, it comes up with a message. We'll talk about what this traceback does, but it does something very important. It writes something to the log, and it sends a short email message to a bunch of people, and this goes to, for example, Matt's cell phone, so that he knows that there has been that the instrument has stopped. This is sort of a creature of last resort. We don't want to get here, but if the data collection is going to fail, we don't want it to just stop. We want it to first do something. Okay, so how does that that try statement work? Well, we have try followed by a block of statements. They're indented, so they tell us what the, so that we know where that block of statements goes. We then can have multiple conditions that we trap for. So except value error, get the error message, then do these statements. Except some other condition, and so on. If we put except here and we don't specify a condition, then it means respond to all errors. Okay? And then these things are a little unusual, but there's an else statement. Else will run, the block of statements in else will run if there were no exceptions. And we also have this finally. Finally statements will always be run even if there's an uncaught exception. So if there's something that you really want to happen, you stick it here. Okay? So sometimes people will put things like, they'll put cleanup code into finally. So if you're, if you're doing something, you're setting aside some gigabyte of memory for dealing with some large array. When you're done, you want to get rid of it. So even if if there's an error in there, you don't want that array to be sticking around, and then to ask for another one and another one and another one because you'll run out of memory. So you might have some cleanup code there. These things are a little unusual, and you may not find a strong use for them, but they can be very convenient once you get used to the idea that they're there. Okay, so when you can, you want to work in such a way so that your program responds to a specific error. So here you don't have to worry about what exactly the syntax is because this is called a list comprehension, and I think it's sophisticated enough that I don't really need to even teach it. It's a convenient way of making a for loop into one line. But I'm making a list, and if I somehow were to have a dictionary, I have a value in my list that's not in my dictionary, I just generate an error message and continue. I don't suggest on a regular basis you use this idea of using except either with no error class or except on exception, and then just continuing is not a good idea because you don't know what error is going to occur. So do you really want to ignore it? It's better to, when you can, trap for a specific error or a specific set of errors and then respond to those. So it's not a good idea to just put these things in willy-nilly. Because it could have been an error that you weren't anticipating and you want to know about. And you could cover up a bug in your program by ignoring an error, and then you'll hit some other error someplace later in your program, and you won't have any clue as to what caused it because you've just buried it in this. Except in the case which I gave you before on the beamline, where I've got to stop anyway. So if you're going to stop anyway, then you may want to trap all errors. Okay, you're not required. You can also create error messages, error levels of your own. So, and I'm doing this in my own code more and more often. I will run through a certain point, and I'll get to a point in a subroutine, and it's clear to me this subroutine only has at this point, it can only fail. Okay, I've come to a certain point. I want to do a certain set of things. My input is invalid, or something like that. My conditions aren't right. I cannot continue, so therefore I need to get out of that routine. I will use the raise command followed by the name of an exception class that I'm going to use and an optional error message, and I will trigger an error. Why do I do that? Well, the idea of this is that you're running along through your code. If something happens, you want to do something, so you have an if statement. When you trigger an error, that's saying, I don't care how many levels down I am in my subroutine. I don't care where I was called from. Something major has happened. Go use the error handler at the top level. So it's sort of so this raise command can be thought of, get me the hell out of here. I may want to continue doing something, but I'm not. But I want to. But I don't have any business being at this routine. Yes, question. So, say that again. Actually, it's the other way around. You probably would have the try, the if statement. Yeah, the if statement would be inside a try block. Yeah, yeah. So, but you can think about it as when you're writing your code, you'll do certain things, but if all else fails, if you get to a point where you can't continue, you just do a raise, and that gets you out of there, and it will get you all the way up to wherever the the exception handler is, if there is one. And if there isn't one, it will stop your routine from running. That's going to depend on the program you're writing. Okay, so when you're writing a a subroutine, you have to say, okay, I can't continue at this point. But when you're incorporating that routine into your own code, at that point you'll say, well, okay, this may fail with the following exception, because I know that, because the code will, when you document your code, you'll see that, and you will say to yourself, okay, if this fails, what do I want to do then? Yes. What's that? It depends on what you want to do. I mean, if I'm doing if I'm doing something which is going to read a file and plot it, if it fails, it fails. There's no reason to do any error handling, because I'm sitting right there, and if the file turns out to be empty, okay, I get an error message saying the file doesn't have any points to plot. Fine. But if I'm doing something where I want to open a file, plot it, and then come back 3 minutes later and plot the latest update, I want to just simply at that point put up a message saying no data to plot, go back to sleep. So it really depends on what on what you're doing as to what makes sense to do. Yes. Can you step through the code while you're testing? You can do that in some of the IDEs. So if you want to do that, you can do that with things like breakpoints. I don't know if you can do step-by-step execution in all of the IDEs, but certainly some of them. So to do that, that's where, I think it was 3 lectures back or 2 lectures back, I mentioned WingWare. WingWare Wing 101 is a free IDE. Eclipse will do that. I think that Idle will do it as well, but I'm not sure. So yes, you can do line by line running of code. Okay, so what exception do you put here when you're writing your raise command to create an error? Well, if you have nothing better, I mean, if value error makes sense, the one we saw before, you can use it. But if there's no error that makes sense, you have 2 choices. We could talk about how you create your own error category, or you can just use the base class, which is called exception, and that's fine too. Why wouldn't you want to use just exception? Well, because as I was saying before, if you want to then respond specifically to my error, then you can't separate that from exception, any other exception if you use this. Okay, so it's better in your own code to create an error that's specifically yours so that you can catch it and handle it. All right, so some cases you'll actually trap a particular exception and then raise something different. So my previous example, I am anticipating that I might get a key error. So in this little bit of code here, I anticipate that I might get this key error. When I do it, I do some sort of logging of some sort, and then I raise a different exception so that I trigger something that I want to handle. And I might have my routine raise my exception 5 different ways, depending on where it is that it comes to the error. But it's perfectly appropriate to catch an error only to generate a new one. It's catching an exception only to generate a new exception. Okay, how do you create your own error class, exception class. Well, we haven't talked at all about how you define classes in Python, what they mean. So you can just sort of look at this as blueprint code. You will copy this code, and you'll just stick the stuff in that you need. So you define a if you want to you'll get an error, some error information, and so you define this here, and all you have to do is to fill in these two parts here. You don't even really need to do anything there. You just create the error message that you're going to get. So here I have a raise my error, and I pass it an argument, which in this case is 42, and you'll see that the 42 gets stuck into my error message, and that's really all you need to do, is to define. If you just simply follow this, you can change this code here, you can change the name there, and you're done. You've defined your new error class. So it's just basically why this is working and what we're doing will become more clear when we talk about defining your own classes, but that's what we're doing here. So if you just stick this code in, changing that name, it will work. You really do want to change the mixed metaphor here. Okay, so why do we want to use exceptions in a routine? Well, I talked about a little bit of this already. If you imagine that you've got a stack of routines, routine A calls routine B, calls routine C, calls routine D, sometimes, but maybe sometimes D gets called directly by A, and you want to hit a condition, and then you want to return out up through all these various levels of code, and then trigger something different. That gets pretty complicated to write. You've got to, we return out, where am I, what do I need to do, what level of return, how do I trigger returning all the way out. That kind of code gets very complicated to write, but if you throw an exception, then you know that it's going to just go back to the top level, to I guess lowest level error, the most the most recently called try block. So if this do something calls any other levels of routines underneath it, we really don't need to worry about where we are in that code. As soon as one of those routines does a raise my error, I'm going to go immediately to process error. So for those of people who are thinking, who've written Fortran code, this is kind of like a go-to statement, but it's a go-to statement in a very structured and very easy to follow way. So think of raise as get me out of here. Okay. All right. So a little more style on this, style issues. It's often a good idea to trap both expected and unexpected errors. Okay? You have your code running, you use at the, just when you just first get it started, you put it in a try block, and that try block will respond to all errors. Okay? And it will do some kind of logging or something like that. And then, as it's running, inside that big try block, we have more tries, and those things will respond to specific errors. So my code will handle both expected errors, and when I have an expected error, it can do something in response to that. But it can still deal with unexpected errors and, for example, write information out in a log file that will help me track it down later. One comment, if you're writing code that other people are going to run, one of the problems is they come back and tell you, yeah, I hit an error yesterday. This is what I was doing. Did you save the error message? No. There was some sort of traceback thing, but I didn't do anything with it. Oh yeah, and I closed the routine and closed the screen and logged out when I was done. So by responding and saving the information you need, Matt never does that. Matt, I get an email with 50 pages of stuff. So we'll talk next week. We'll talk about doing EPICS communication. EPICS communication, at least with the CAUtil package, does trigger exceptions from time to time. You give it code that worked 50 times, 100 times, and then maybe once out of 100 times it will trigger an error. You do it again and it works. So unless you don't care that your code is going to crash that 1 out of 100 times, you put it inside a try block. So the main routine, as you saw, has a try block, and if anything unexpected happens and the program crashes, save what you're doing, put that information somewhere, maybe an email message. But then inside that, you'll have lower level routines that use try to capture errors and respond to and respond in different ways. Okay, so you may be able to do something like that with try and then accept value error, do this. Accept type error, do this. Accept my error 1, do this, and so on. But it's much more common to nest errors. So you have a try block at the top. If all else fails, do this. And then in little bits of your code, for example, when you send out one EPICS command, you want to recover by doing this. You send out a different EPICS command in a different place, and you do something different. Excuse me. Okay. All right, I alluded to this earlier, and this is really not necessarily part of exception handling, but tracebacks. Okay. So here I have a series of routine. Junk is going to trigger an error because I divide 0 by 0. And then I define a routine called call junk, which calls this. And then finally I actually try calling it. And when I do that, I see all this stuff displayed. And what this is it's telling me what actually happened. And you can sort of read this from the bottom up. Well, what happened? This is our error, zero division error. And zero division error, integer division, or modulo by 0. Well, that makes sense because I divided 0 by 0. And then it shows me that in trace demo line 2, in routine junk, I had this statement which caused the error. Okay, well that makes sense. It hit this while it was doing that. Then we look above it and we see that in line 5, in routine call junk, that statement there was the one that brought us to there. Well, that makes sense. And then finally, we see in line 7, which corresponds to that, call junk is where we started. So this is showing us, in a sense, a stack of routines. We did this, we did this, we did this, and then reading it backwards, from here we see where we were. So this is called a traceback. And it can be really useful in figuring out how did we get to a particular place where we hit an error, because our routine junk might be called in 50 different places, and just simply knowing that we hit an error in routine junk doesn't help us figure out how we got there and what we did wrong. So a traceback is a really good way to find out what's going on. Well, how do you get this to keep? Well, it turns out that there's a whole package within within Python built in called traceback. We haven't talked too much about how we do this, but so again, this is sort of boilerplate code until we get to a little further. But so we ask to use traceback, and while I'm at it, I'm asking to use the datetime package. And instead of before where I had where I just did call junk, I'm putting it now inside a try statement. So try call junk, and if I get a zero division error, then, and we'll talk about what this stuff does, but here I'm opening a file and I'm catching my error, and I'm sticking I'm sticking the information into a file. So this would allow me to, so when I run this version here, the trace demo 2, it puts it into a file for me. And I've added a timestamp that tells me when the error occurred and the traceback. So that's some very simple error handling that you can copy to your own code to allow you to get a log that will tell you where your error occurred. Now, I know there's a lot of stuff you're seeing here for the first time. You're seeing that this import stuff and the file handling. As a matter of fact, the next thing we'll talk about is how you deal with files. But I just wanted to have something in your notes, an example to follow about how to capture a trace back and put that information into a file. Okay. So, something for you guys to try. Take a list. Here, I've given it to you right here. Divide by 10. If you don't get an error, print out the result when you divide by 10. When an error occurs by dividing by 0, print out divide by 0 error. And when an error occurs due to dividing by a string, you print out you cannot do that. You can use the contraction if you want. Okay, so let's give you a little bit of a chance to see how to use the try block. Yes. Sure. The easiest one is to do it. Okay. You could start by writing this code without the try. And then when you get your first error, you add an exception for that, an except clause, and then it'll run further till it hits the next exception. Then you'll see what that one was. But it'll also give you a good example. If you do try and then except, you'll see that you never see the error. You have to, that's a bad thing to do.